So chapter 41 is going to be about nutrition and different types of organisms and the way that they get their nutrition and how just by looking at them, sometimes you can figure out what they eat. So obviously we're going to be talking about heterotrophs because we're talking about eating something. And heterotrophs can be divided into being herbivores, carnivores, or omnivores. So as far as the vertebrate digestive system goes, it's pretty basic. Whoops. Sorry, I don't know why that's coming up there. And so here's the basics, right? You've got your mouth and you've got your teeth and your tongue, everything going on in there. That's going to lead to your pharynx, which is going to be the common passageway from your nose and your mouth. That's going to lead to your esophagus, finally goes to your stomach. Which is going to have some accessory organs associated here. We've got our liver, our gallbladder, and pancreas. Then we've got our small intestine. That's going to lead to your large intestine, and that's it. So we're going to kind of go through each of these and take them away piece by piece and talk about what each of them actually does. So your liver, we're going to come back to again, but it does produce bile, and the whole point of bile is to break down fat. So it's an emulsifier, basically. Your gallbladder stores the bile that your liver makes. So you may have heard of people living without a gallbladder, and that's not a big deal because the thing that's producing it is still there, your liver. You just can't store bile. And then you've got the pancreas, and the pancreas is going to do a lot of different things, but digestive-wise, it's going to create insulin. And the whole point of insulin is to control blood sugar. Okay, so now what we're going to do is kind of go through the whole path, and we're going to follow what's called chyme, C-H-Y-M-E, and that's just the ball of food that's going through your digestive tract. So first you've got the mouth and the teeth, and the mouth and teeth are going to help to mechanically start to digest the food. Now birds don't really have teeth, reptiles too, so a lot of them will actually eat up pebbles and rocks and things, and that helps to churn up the food for them a little bit more easily. So if we're talking about vertebrates, they're going to have teeth, and they're going to have three basic types of teeth that we have listed here. So you've got your incisors, your molars, and your canines. And depending on what type of diet an organism has, it's probably going to have a different setup of teeth. So the incisors are going to be used more for like biting and tearing little pieces off. Then you've got your canines. Your canines are used for ripping and tearing things like meat. And then you have the molars, and the molars are kind of wide and flat, and those are going to be used for grinding up food. So depending on what the organism is eating, they're going to have a different setup of teeth. So if you look at a carnivore, they're going to have very well pronounced canines, and they're even going to have pointy molars, right? And if you look at an herbivore, they may not even have big canines, if at all. And then they're going to have really well-developed flat molars, and that's for chewing up their food. And then if you look at an omnivore like us has all three teeth fairly well represented, right? So it's really interesting. You can just look at an organism's teeth and kind of figure out what it used to eat. Okay, so in the mouth, what's going to happen, your tongue is going to mix your food with saliva. And if you remember from Bio 111, saliva has salivary amylase in it, and its whole job is to break down starch. So then that ball of food is going to go into the esophagus, and that's going to connect to the stomach. And what's going to happen is you're going to swallow, and it's going to use peristaltic contractions, and that's going to bring the food down to your stomach. So when you get to your stomach is going to do two types of digestion, mechanical and chemical. So mechanical is going to churn it up, and chemical, it's going to mix it with hydrochloric acid. So what's kind of crazy is, you know those 2-liter bottles of pop that people buy, like Mountain Dew or something like that? Our human stomach produces 2 liters of hydrochloric acid, which has a pH of 2, every single day to digest stuff. Now, what's cool is hydrochloric acid isn't just used for digesting, it's also going to be used for killing off a lot of bacteria that's on our food. So it's really interesting when people, like my husband, is on an antacid, a prescription antacid, and it actually says on there for him not to eat things like sushi and raw oysters or anything like that, because he doesn't have that extra acid in his body to kill off a lot of that bacteria, which is fine with me. More food for me. I'm always down for that. But kind of interesting how that works. Now, the acid is fine when it's in your stomach. When it starts to move into places it shouldn't go, then you can have ulcers. And so ulcers are going to be where it basically like eats away at the lining of your intestine. So that being said, you've got your small intestine and your large intestine. Now, your small intestine is going to be where a little bit more of the food particles are getting broken down, but it also is going to start with a little bit of absorption. So what's going to happen is the wall of your intestine actually looks like it's made of a bunch of little fingers like this, and that's to increase surface area. And those are called villi. And what's going to happen is you've got your pancreas, which is going to be an accessory organ that's going to help to neutralize the stomach acid that's coming in, give you enzymes to help do a little bit more of that breaking down. But it's also going to do something called regulating blood glucose, which is the amount of sugar that's in your blood. So what happens is if you look at the absorption in your small intestine, it's going to break things down into monosaccharides and amino acids. Those are the building blocks of our carbohydrates and our proteins. And so what's going to happen is those are going to get into your bloodstream. So the pancreas is going to get a trigger that, oh, we've got blood sugar in the bloodstream. It's going to make insulin, and that brings the blood sugar back down. So if you're talking about someone who's diabetic, they may not know how to create insulin, right? That's basically how it goes. And there's two ways that can happen. Either it's not in their DNA, so their body doesn't even know how to make insulin, or they may have eaten their way into it where they have desensitized the sensors, and so the sensors just don't know that it's time to make insulin. Okay, then you're going to have your large intestine, and your point of your large intestine is purely for absorption. It's going to absorb three things: water, sodium, and vitamin K, which is potassium. So let's say that you eat something, and by the time it gets into the end of your stomach, beginning of your intestines, your body is like, oops, you shouldn't have eaten that. It's going to get rid of that as fast as it can, right? So it's going to go through your small intestine and get to your large intestine. Now, when it gets to your large intestine, it's going to shoot through there as well, which means that your body doesn't have time to absorb water, sodium, and vitamin K from whatever that food was. That's how you end up with diarrhea, right? And that's why when people have diarrhea, the first three things they want back in their system is water, salt, and potassium. Okay, now there is a vestigial structure, that's a word from like way, way back, called a cecum. And we've got one right here, and it's very closely associated with our appendix. The thought is that that used to house bacteria that helps us to break down cellulose. And now that we've moved from eating less plants, then that's why we don't really need that anymore, and it's becoming a vestigial structure, and that's why it gets infected because we're not using it and that type of stuff. So the cecum is going to be really interesting because once again, you can look at the digestive tract of an organism and figure out what their diet must have entailed. So if you look at this coyote right here, you can see it has a tiny little cecum, and that's because it's mostly a carnivore, so it's not really going to eat many plants, and it doesn't need that bacteria in the cecum. Whereas if you look at this koala bear, who's a vegetarian, right, or an herbivore, you can see that the cecum is huge in these guys, and that's because it harbors that bacteria to help break down the cellulose that they're eating in those large quantities. So that's going to be the cecum and how you can tell the difference. Now, the koala was going to be what's called a non-ruminant herbivore, okay? And then these two are going to be more carnivorous that we were talking about there. Notice the carnivores have either no cecum or a small cecum, whereas the non-ruminant herbivore is going to have a large cecum. Now, if we look at what's called a ruminant herbivore, they're going to have a completely different setup. So a ruminant is going to be something that chews their food twice. So the non-ruminants are ones that just chew their food and that's it. So a cow is a perfect example of a ruminant. And so what they're going to do is they're going to eat their food. It's going to go into this area called the rumen, where it's going to mix with some protists and some bacteria that can help to break it down. Then it's eventually going to come back up to their mouth where they're going to chew it again, and then they digest it. So it's a much more complicated process, and that's just the way that those guys are set up. So that's the difference between the digestive tracts of all these guys. Now, one accessory is going to be the liver, and the liver is a really important organ. People just don't realize how important it is. So yes, does it create bile? Definitely. But it also is a filter, right? So it helps to metabolize alcohol and drugs, gets rid of toxins, regulates hormone levels, and a lot of people don't realize it actually makes proteins that you have in your blood. So it's a very, very important and diverse type of an organ. It does a lot of stuff. Then the next thing here is what we have called essential nutrients. You've probably heard of these in like TV commercials for food and cereal and stuff. And then essential minerals. And these are going to be things that we have to ingest because even if our body has all the building blocks to make these, your body just doesn't know how to. So you have to get it from your diet. So vitamins, water, those types of things. As far as essential minerals, we've got calcium and iron and those types of things that are helpful for structural processes in the body. And then what we're going to finish with are going to be the 4 main ways that animals can feed. So this is always a fun one. So the first type is going to be what's called a suspension feeder. And a suspension feeder is sometimes also called a filter feeder. So like whales are going to do that, clams, those types of things. And what it means is that they're going to take in a huge amount of water and then pick little pieces out of the water that they want to eat. So plankton, little krill, stuff like that. So those are suspension feeders. The next type is going to be, if I can get it to work, a substrate feeder. So you can see this caterpillar is actually living on the leaf that it's feeding off of. So that makes it a substrate feeder. It's living on or within what it eats. A maggot would be another example, right? It's living on what it eats. Then the next type is going to be what's called a fluid feeder. And fluid feeders actually suck a fluid out that they need from some other organism. So this is actually a mosquito sucking fluid out of someone's skin, sucking blood, right? A nicer version would be a hummingbird that's sucking nectar out of a flower. So those are going to be fluid feeders. And then finally, what we are, and this obviously, the snake, is a bulk feeder. And bulk feeders are going to have large amounts of food over, and then they can kind of go for a long period of time in between. So snakes are just a perfect example of that. But we are too. We don't eat constantly. We eat, meals, and then we can go for a while without. I always love to show I think I showed you this in class, but the most gluttonous snake ever, the greatest example of a bulk feeder. So this was a snake that ate an alligator in the Everglades because people have been releasing pythons there and they don't have a natural predator, so they're getting really big. So what you see here, down here would be the head of the snake, and then here's the tail of a snake over here. And the alligator's head would probably be like right around here. Here's the alligator's feet, and there's his tail. So basically what happened was the snake actually exploded because it ate something so big. I felt like that after some burgers sometimes, Anyway, so that's going to be the 4 different ways that organisms can feed, and that is the end of this chapter.